Okay, let's take a look at the type of question that you might be asked about mixing strong acids and bases together. Remember that by strong acid and base, what we mean is a substance that ionizes 100% when we put it in water. And please note that I have put this handout into your notebook so you can follow along on this question as I do it in the video. So in this particular question, we're going to mix a strong acid, HCl, with a strong base, NaOH. We've got 25 milliliters of the HCl, it's 0.25 molar, and 35 mils of the 0.2 molar NaOH. And our question is asking what is the pH of the solution once we mix the two of these together. So first thing we need to do is we need to figure out what is the reaction that we're talking about here. So write out the reaction. Firstly, the formula reaction. So formula reaction, we have our HCl, which is aqueous, NaOH, which is also aqueous, and an acid-base neutralization. What is going to be produced is a salt, in this case NaCl, and water. And water is a liquid as opposed to being dissolved in water like everything else. Complete ionic equation. So remember, for complete ionic, what you have to do is you break apart any of those substances that are aqueous into their constituent ions. So we have H plus, Cl minus, Na plus, OH minus. To be more proper, you should be putting your aqueous for all of these. Also, we're going to actually make this a double-sided arrow, and you'll see why in a sec. And this is going to be Na plus Cl minus plus our water. And then net ionic. Remember, when we write our net ionic equation, we cancel out anything that exists on both sides of the equation. So our Cl and our Na cancel out. They're hanging around in the water before, they're hanging around in the water after. They've not actually done anything in the reaction, which means all we end up with here is our H plus OH minus turning into water. So that is all that is happening in an acid-base reaction, is that the water is being produced and then water is breaking apart again. Remember that always water is undergoing that self-hydrolysis reaction where it's breaking apart into OH and H plus as well at a very minuscule amount. Okay, next part, step 2. We're mixing two solutions together. So we have to do a dilution calculation to figure out what is the concentration of our hydronium and what is the concentration of our OH in this particular solution. Remembering that this H plus is actually hydronium, not just H. So using the initial concentrations that you have, we know that the H3O plus has a 1-to-1 ratio with our HCl, because there's one H plus ion in there. And it's just a dilution calculation. So the initial concentration is 2.250 molar. Initial volume is 25 milliliters of our HCl, and then our final volume is the mixture of the HCl and the NaOH, which is 60 mils. Multiply the top, divide by the bottom, and this gives us 0.10416 repeater molar. And I've written down quite a few digits there because I'm not going to round it off until I get to the end. Concentration of our OH minus is going to be the same as the concentration of our NaOH solution because there's a 1-to-1 ratio there. Our initial concentration of the NaOH is 0.200 molar. Initial volume 35 mils, and total volume is going to be the same as here because we're mixing those two solutions together, which is 60 mils. Divide this out and we get 0.116 molar. Okay, so think about what we're doing here. We're taking our HCl solution, we're mixing it with the NaOH. What is happening? the solution are neutralizing one another. So the H plus from the hydrochloric acid is reacting with the OH from the NaOH. The amount of each of those solutions that is equal, the concentration that is equal, the number of moles that are equal, neutralize. Whatever else is left is going to determine if the solution is acidic or basic. So that's our step 3. Figure out if we have excess hydronium or excess OH. And we're doing that by looking at our concentrations here. So you can see the amount of OH that we have is greater than the amount of H3O+, plus, so it's going to end up being basic. So we have an excess of OH minus. How do we figure out how much? We just simply subtract those two numbers. So this is 0.11. I'm going to put a 7 because this is 6 repeater, minus our 0.104 is going to give us 0.013 molar. That is going to be the concentration of OH minus that remains in the solution after we've mixed the two together. And that's what we can use to figure out the pH, which is our step 4, figure out the pH. Now, we have an OH concentration, so what I would do is first figure out a pOH concentration. Remember, pOH is negative log of the OH concentration, so we can plug this number in here, negative log of our 0.013 molar, and this gives us for a pOH 1.89. And then from that, we can calculate our pH, remembering that pH plus pOH equals 14. So pH is going to be 14 minus 1.89, which equals 12.11. And think about it. Does it make sense? The solution is basic. 12.11 is the basic pH. Yes, it makes sense. So those are the steps that you want to go through. Realize that this is the equation that we're actually talking about. We don't need to necessarily do this every time because it's the same reaction if we're mixing a strong acid and base together. Figure out what is in excess and then use that excess amount to figure out the pH of the question, of the resulting solution. So let's take a look at another question that's worded a little bit differently and asking you to find something different. This one says how many moles of hydrochloric acid must be added to 40 mils of a 0.18 molar NaOH solution to produce the solution that has a pH of equal to 12.500. Assume there's no change in volume when the HCl is added, or we would have to do some sort of dilution to start with. So let's take a look. We have an NaOH solution. This is what we have. We have NaOH. We have 40 mils of it. And it's a 0.180 molar solution. We are going to take HCl, and add it in here. We don't know the concentration of this. We're looking for the moles. So we can figure out how many moles do we need to add in there. And again, that's part of why the volume is not changing, so we can just assume that we can figure out how many moles there are that are going to be added there. But what we want, this is our key point, is that at the end, we need to have a pH of equal to 12.5 molar. Now, 12.5 molar is a base. 12.5 pH is a base. So we are, once again, dealing with the OH concentration is what it is that we want to look at. So what we need to do is we need to figure out, well, how much OH do we have to start with? How much OH do we need in the end? And therefore, how much of the hydrochloric acid is added in order to make that change occur? So our new OH concentration. How do we figure that out? Well, pH is equal to 12.50. This means that POH is 14 minus 12.500. So our POH is 1.500. We can use this to figure out our OH concentration, realizing that we know that the concentration of the OH minus is going to be 10 to the negative POH, which is 10 to the negative 1.500. And this equals 0.03162 molar. That's where we want to end up. Where did we start? We started with 0.180 molar NaOH, which means this is also equal to the concentration of the OH minus. So how much has it changed? Our change in OH concentration, we need to subtract the two of those. So we have 0.180 minus 0.03162. Our change in OH is 0.148 molar. Now, why did we have that change? We had that change because we added acid to it. So we're adding the HCl to the NaOH in order to make it become less basic, to decrease the concentration of our OH that is in there. Which means that this is the amount of the hydronium that was added, which means this is the concentration of the HCl that was added. And from there we can figure out how many moles of HCl we would need to add, because that's what you're ultimately asked to find, is how many moles of HCl were added. So we want moles of HCl. If this is the concentration, 0.148 moles per liter, and we know that the volume was 40 milliliters, which is 0.040 liters. We can multiply this together and it gives us 5.94 times 10 to the negative 3 moles. Okay, so we're doing a similar thing here, but this time we're asking how much do we need to add of our acid to change the pH. So we need to figure out how much has that OH concentration changed. Therefore, we're dealing with pH. If instead we had an acid solution and then we were adding OH to it, we could use the pH and the H3O plus concentration. The only other thing that I want to make note of here is that in both of these examples, we've used HCl and NaOH. If we use something instead like HCl and calcium hydroxide, so let's say that that was our base, you need to be aware that in this case, if we're looking at the OH concentration, it's going to be twice the concentration of the CaOH, because there are two OHs in every 1 mole of the calcium hydroxide. So just be aware of that. In both of the examples, it was just a 1-to-1 ratio, which made it nice and easy, but there may be a situation like that where you have to multiply it, so be careful. Okay, go try some of these questions.